Hey guys, so today I'm gonna show you some of the physics questions and more topics we've been doing at school, and you guys seem to be having trouble with that. So I'm gonna start off and possibly do the only thing, projectile. So let's start off with the very basic. Let's draw a simple projectile. Give me a second. All right, there we go. There, visual too. Okay, so we have an object here, and right there, and we project it by some distance. Yeah, it goes pretty far. Okay, so let's say this is a flat plane. Stops right there. Okay, this is a very flat plane, and it finishes here. Now let's work with this for the tactic. So first, when you get a projectile, is obviously you draw this line, okay, which is horizontal. Make sure that the height's the same, and then you continue on. Make an arrow here. All right, just keep it like that. Then from this initial position, you draw an arrow. Right? You draw an arrow going straight up. Okay, like that. So basically, we've made a graph. And so what this does is like lets us calculate what we're doing. So let's write down what we have here. From here, the launch, we have an initial speed called u. Okay, so the direction of u will be this way, obviously, because since it's a vector, this is the direction of u. Okay, right there, u. Now, the length of the u doesn't really matter because the magnitude of this isn't really the length. The magnitude will be a given magnitude, obviously. And so it is launched at an angle, let's call it theta. Alright, that's theta, the angle. And now, what we want is to split this direction, okay, back to where we were. An angle will be given with an initial speed with that direction. Now, to calculate things that are happening within this scenario, we need to divide this vector into two. So I would make a line here, and I'd make a line here, and so I'd call this line ux. Okay, yes, and this is uy, right? Yeah. So now dividing this thing into two makes my life much easier for calculating, even though it will look like that it's a lot of work. So let's get started. This is our u, so ux. Now, basic trigonometry and basic geometry will say that this is ux2, this is uy, makes our life much simpler. So to get ux, we need let's see, this is ux equals u dot cosine theta, and uy equals u dot sine theta. How did cosine and sine theta happen? This is basically basic trigonometry. We have the hypotenuse, and the ux is the base, so we use sine, and uy is the opposite, and we have the hypotenuse, so we use sine. Sorry, for ux we use cos, for uy we use sine. Don't get this mixed up like I just did. Sorry about that. I know I sound like a hypocrite sometimes. Okay, we have that. Now, let's that's the first thing we work with. So what this will do is show us at what speed the ball will be launching this way, so upwards, and what speed the ball will be launching this way. Now, two things we need to take into account is that in the x direction, okay, this is the x direction, this is the y direction. In the x direction, no acceleration. Okay, so let's say we'll work with a x direction first, so x direction. So what this will have is ux, which is, we go here, u dot cosine theta, and the acceleration, okay, ax, we're gonna call this ax. Sorry about that, something happened. Okay, and so in this the x direction acceleration, we're going to call it ax, equals 0. That's right. There is absolutely no acceleration in the x direction. So then what would be vx? Yeah, the final velocity in the x direction. So like, what would be the final velocity once you reach here? Well, it's much simpler than you think. Let's take the normal equation. V is equal to u plus at, right? Since there is no acceleration here, we have ax of 0. We cut this, v equals u. So vx in direct form is ux. Simple, because there's no acceleration. Whatever speed you started off moving this way will be the same speed you end up in that way, because there is no acceleration. This is one of the universal rules that we're going to use. So ux is u cosine theta. Again, this is the x directional formula. Alright, this is what we do in x direction. Now let's talk about y direction. This is a bit tricky. The y direction, it goes up and comes back down. Isn't that what's happening? It goes up and comes back down if you're seeing from this perspective. Up and then back down. So this means there is acceleration. Alright, so this is again in terms of velocity and acceleration. For range and distance, there will be, I'm not sure if there's a separate video, it will be a part of the same video, but I'll explain the distances also, but not exactly. So let's see what's happening in the y direction. In the y direction, there is acceleration, okay? But before we get into acceleration, let's just go do the simple thing. Uy, we'll start with uy. The initial speed at the y direction equals u sine theta. We know this from this, right? And then acceleration in sine theta, in y-axis, okay, or in y-axis only, your acceleration will be minus g. That is also a universal rule. These are stuff you have to memorize, like vx, ux, u cos theta, ax equals 0. Okay, these are not dedicated to just this scenario. This is dedicated to any two-dimensional projectile scenario. Okay, so ay equals g minus g, which is minus 9.8. Simple. These are universal laws, by the way, so you can't like really alter them. These are stuff you have to memorize. Then what will be final value of vy? Keep messing this up. I'm so sorry. Vy will be what? Well, we'll go back to this equation. Okay, I'll write this again. V equals u plus at. Vy, okay, we have the value of u, which is uy, because we are talking entirely on the dimension of the y direction. Okay, we forget the x. We are done with the x. This is our x part. We are done. Now we are working only with y. So whatever u you see, or a or v, there will always be y when we're talking about the y direction. So yeah, I should have done this. Okay, let's write this again. V equals u plus at. Okay, vy equals uy plus, in brackets I write minus g, and time sorry, and time is an independent variable. It does not care what v is or u is. It is absolutely independent, and it's basically a constant, if you could say. So if I put the values of uy in this thing, values of uy into this, what I get is vy equals, write it in brackets, u sine theta. Okay, this is a minus here, this is a plus here, they multiply, they become minus. I'll do it in brackets again, gt. This is the equation for vy, u sine theta, and if any one of you don't know, these dots, they mean multiply, minus gt. Right, this is the equation for vy, and this is what I wanted to explain it to you guys. Okay, these all right now looks like a big hell of a mess, and it is, but if you wanted to calculate this separately, I promise you, you will have such a hard time doing it. Alright, the light keeps going. So this is, let's say, part 1 of this video. Thank you for watching.